Again, this video is on section 3.1. Again, it's on homework assignment number 31. This graph we're going to look at zeros and multiplicity. Now remember, again, you won't be graphing, but you've got to know some traits and characteristics of graph. When we talk about finding the multiplicity, we're going to use the power of the factors. Power of the factors. Multiplicity represents the number of times a zero is used. On a graph, it represents the number of times the graph will cross through the axis at a zero. Multiplicity, even. If the multiplicity is even, the graph will touch the x-axis, not turn around. If the multiplicity is odd, the graph will cross. For example, at this point, this graph crosses the x-axis from below the axis to above it. Therefore, that zero has a multiplicity that's odd. Here, you see the graph touching the axis, coming down, touching and going back, reversing directions. That means that because of this touch, the multiplicity of that zero was even. Now let's take a look at some of these. If you have this first problem already in factored form, remember to solve a polynomial, you'll set each of these factors equal to 0. So if I set x minus 1 squared equals 0, if I took the square root, I'd just have x minus 1 equals 0. Note the power doesn't have a cause of an answer. Then that would be x equals 1. Now that 1 is my 0, and this exponent that goes with that factor is my multiplicity. In the second one, x would equal negative 2. The understood 1 power would be multiplicity. X minus 4 set equal to 0, x would be 4, that's the 0, the 1 would be the multiplicity. Now because this multiplicity is 2, not the 0, but the power, that means that at that point the graph will touch the x-axis. This multiplicity is odd, this one is odd, it would cross the x-axis. You will be asked on your final exam to list zeros and multiplicities for a function such as this. In problem number 2, I'll set each of these factors equal to 0. So x minus 1 becomes x equals 1 with a multiplicity of that exponent, which is 2. X minus 5 set equal to 0 becomes x equals 5. Multiplicity is that power, 3. X plus 3 becomes x equals negative 3 with the multiplicity understood 1. Now again, because that multiplicity is 2, that graph would touch the x-axis, not cross. Problem number 3, I've given you a little hint that it's not completely factored. So what I would have to do is to bring down the negative x, I would factor x squared minus 4 into x plus 2, x minus 2. Now the x would equal 0. There's a power of 1, so multiplicity 1. X plus 2 becomes x equals negative 2, power of 1, multiplicity 1. X minus 2 becomes x equals 2, that's my 0, and the multiplicity is the power 1. Problem number 4, again, you're going to have to factor this. They didn't factor at all. So I'll first take out a common x squared, which leaves me times x squared minus 9. That's the difference of two squares, so that would factor into x plus and minus 3. Now if I set these three factors equal to 0, I have x equals 0, x equal negative 3, x equal positive 3. Those are my zeros. This factor, this 0, came from this factor with a 2 exponent. That's my multiplicity. This 0 came from this factor, multiplicity 1. This one from this factor, multiplicity 1. Now notice in this one, because that's a 2, you would touch the graph. Now here you're not seeing graphs, but you get the meaning. We'll look in the next section at what it actually looks like. You will have a question that just says, what is the 0? What is the multiplicity? Number 5, one more time, we're going to factor, bring down the x squared. Now I have the difference of two squares here within a factor to the 4th power, so that becomes x plus 5, x minus 5. which would separate into x squared times x plus 5 to the 4th times x minus 5 to the 4th. So from here I would get 0, from here I would get negative 5, from here I would get positive 5. The 0 has a multiplicity of 2, the negative 5 a multiplicity of 4, and the positive 5 a multiplicity of 4. In all three of these, since these are even numbers, we would touch the x-axis. Now, one complete question for you would be to take a problem such as this and determine what is the 0. Remember, on a graph, that's the x-intercept. And what is the multiplicity? That's the number of times it crosses the x-axis.